All right. Hello, hello. Welcome to the bewildering world of business, in quotation marks, statistics, or as we like to call it here at Westchester University, Stat 543. 543. So it's a little bit of a curious term. I'll confess, right? This idea of business statistics. It's not really a term I think that you'll see a lot in terms of like graduate level statistics coursework. It's maybe not even per se a buzzword that you'll see a lot in like job descriptions. In fact, from my experience, like business statistics is maybe most commonly associated with like a really low level introductory general education statistics class taught by a business department, to some freshmen, non-math majors. That's like very basic, teaching means and medians, maybe a little bit of basic hypothesis testing. But since these are for business majors, it's taught, in this kind of business context. So why is it that we're talking about business statistics right here in this kind of upper level graduate elective class? Well, to me, right, the way that I've branded business statistics, the way that I've branded this class is this really, I think, innovative, flexible umbrella that really encompasses a variety of fields, right? So there's a whole bunch of different subfields or methodologies that I think could fall into, right, this broader idea or concept of business statistics. And as an elective class, we tend to have less students. And so what that's going to provide for us is a lot of different flexibility. So what I'm going to do in this slide is I'm going to kind of give you a tour of this world of business statistics. And then as we work our way through the class, we'll kind of look into these different subfields in greater depth. But in particular, if there's any one of these fields that kind of calls out to you, that kind of fits your particular set of interests, that maybe parallels or coincides with the internship that you're working at, with the job that you're seeking out, feel free to shoot me an email, and we could go maybe a little deeper into some of these topics and maybe I had originally planned to. So let's start here, right, with the idea of econometrics. So, right, this is a term that probably you have heard at a pretty high level. Econometrics is usually thought of as pretty advanced economics. Used at a variety of levels, but often at a sort of PhD kind of research level. Um, right, according to Wikipedia, we could think of econometrics as the application of mathematics, right, in bold statistical methods. Hey, that's us, and computer science to economic data, right? So we're applying our sort of statistical mathematical reasoning and maybe using some computers to assist us, some programming to assist us to economically based data, right? So we can think of this as a branch of economics designed to give empirical content to economic relations. Maybe a smidge redundant, but I don't know. I tend to suck myself down rabbit holes. So, all right, if that's what econometrics is, well, what is economics? Economics is a social science. And that the fact that it's a social science will have some statistical implications that we'll see in a slide or two. It's a social science that describes the factors that determine, right? So it discusses, it studies the production, distribution, and consumption of, right? And here we're being very general, right? This idea of goods and services. So an economy is an area of production, distribution, and consumption, right? These three components defined by these various agents and, right, these very general areas. Economics is traditionally broken down into microeconomics and macroeconomics, right? Where micro is kind of like hyper focused on, or focused on a very granular level. Things like right? The basic building blocks of the economy, the buyers, the sellers, that kind of stuff. Whereas macroeconomics focuses more big picture. Forest versus the trees. Now, from a statistical lens, econometrics focuses very heavy on modeling, particularly, right, linear regression modeling. Um, very, very sophisticated, I should add, right? Very sophisticated forms and extensions, variations of regression modeling, and hence econometrics is a very natural extension and supplement to Stat 512, and so it's probably where we'll end up kind of starting this class, and then we'll kind of see where we go from there. Um, a, a few things about econometrics that maybe differentiates it from maybe a more traditional statistics approach. One is that in econometrics, rather than focusing on a single linear regression equation, econometricians often analyze systems of equations, right? Maybe the most kind of classical is looking at like supply and demand equations, right? Not in isolation, but as this kind of like supply and demand loop. Um, so that's one kind of differentiation. Another is, and we should have expected this, right? This is very common for social sciences. Really, anyone in the social sciences tends to use observational data, and observational data has its kind of own unique challenges associated with it, right? That's contrasted with experimental data, right? Experimental data, kind of the gold standard, what we might see in like a clinical trial type setting. Observational data um, is not gathered through this kind of like controlled randomized process, and there's some drawbacks associated with that. If you haven't already, you'll talk about some of this stuff in Stat 514. um, Another distinction not listed here as a bullet point, so I guess here's some bonus content for you. Econometricians tend to be a little bit more focused on p-values than maybe like a more general all-purpose statistician. So like for example, in 512, right? I taught you, or your professor most likely taught you, when you're assessing the normality assumption, to look at a histogram of the residuals and somewhat subjectively say like, it looks kind of normal, or whoa, that doesn't look very normal. Um, Would instead do some type of hypothesis test. So there's something, I may or may not be pronouncing this correctly, but a Jacques Berea test, which kind of like, it's kind of this test statistic that combines kurtosis and skewness as a way of testing whether or not the residuals follow a normal distribution. So that's one example. In a time series context, there's statisticians tend to focus somewhat qualitatively on this thing called a an autocorrelation, partial autocorrelation plot, whereas econometricians tend to focus on something called a unit root test, which is sort of p-value based or p-value grounded. So another sort of distinction maybe between econometrics and more general statistics. If we'll talk a little bit about it in this class, but if what we talk about feels like not enough for you, if it's just kind of whetting your appetite, here's some references that you could look at. The econometric analysis is maybe like the Bible of econometrics, but I will say it's like pretty high level. It's kind of a PhD level book. I think parts of it would be accessible to you, but parts of it might require some substantial meditating and going over. A slightly more simplified book, but also less comprehensive. One that I like and I feel kind of like fits the general background of our students is Principles of Econometrics by Hill, Griffiths, and Lim. Um, they have they also have an accompanying text that kind of talks about how to do some of their theory. in the context of SaaS, which is pretty nice. All right, so again, that's just of course econometrics is just one part of this kind of constellation that we're building of quote business statistics. Another star in our heavens is what we might think of as decision analysis. So decision analysis, a bit more nebulously defined, particularly as a field of study. Once again, right, I fell back on Wikipedia. I'm a donor, and Wikipedia describes it as the discipline, right? So there we are, the discipline comprising the philosophy, theory, methodology, and professional practice necessary to address important decisions in a formal manner. That is pretty nebulous, right? In practice, it it boils down mathematically to optimizing. In particular, you're optimizing something called utility functions. What this looks like in the business world um, is you're using something called linear programming. Probably the buzzword that you'll see in a relevant job description would be operations research. And this is a subset generally seen of as mathematics. But we can do it. We can do it through spreadsheet modeling. So that's pretty common. It's very common in a lot of business oriented jobs to use Excel. Even though we of course are more comfortable with more advanced statistical software, so you can do this through like spreadsheet modeling. But I think it could be done a little bit easier and a little bit more accurately using something like SAS and R. So time permitting, maybe we'll go over a little bit of examples of kind of like what this looks like and what are some of kind of the different like business problems, right, that we might try to optimize, right? Really the idea is like, if I have like products A, B, and C, and I want to combine them in a certain way into this kind of aggregate product that I'm going to sell, right? Like, what's the optimal sort of proportion, maybe of like A, B, and C? Like that's the type of problem that we would be solving with decision theory. So you can almost, I guess, decision theory, you might think of it as like optimization theory. Um, if you want to get a little bit of extra practice with Excel, it doesn't hurt. There's a pretty solid book called Spreadsheet Modeling. That's all in the context of Excel. If you wanted to instead learn how to do it in SAS, there's a textbook that talks about how to implement this stuff in SAS. So that's kind of this idea of optimization, right? Another subfield of this broader idea of business statistics is something called financial engineering. This is maybe in my theory, in my opinion, sorry, probably maybe one of the more challenging subfields in terms of kind of like mathematical rigor and background. Right, financial engineering is typically seen as like a multidisciplinary field, right? It involves like a financial theory, so you want to have like a pretty strong background in kind of the context of finance. Methods of engineering, very much tools of mathematics, and the ability, of course, to implement this through programming. I mean, programming is not anything that we shy away from. Um, Financial engineering draws on tools from applied mathematics, computer science, statistics, and economic theory. In its broadest definition, anyone who uses technical tools in finance really could be called a financial engineer, right? So that could range from anywhere from just like a computer programmer at a bank to, right, a statistician at like a government like economics bureau. Um, Right. A lot of the roots of kind of this financial engineering, right? When you get into things like the Black-Scholes equation and stuff like that, um, and it kind of gives you an idea of like why it's so heavily mathematical. Is back in the Cold War, right? Once that was over, um, there was a whole slew of like big brain physicists that were working on, atomic bombs and all the science and physics and mathematics behind that. And when the Cold War was over, many of them were out of jobs. And so, right, this kind of entire like cognitive apparatus was sort of looking around for like some new context to try to kind of model. And many of these big brains sort of turned, um, from whatever, from physics and atomics to finance, and they started really trying to come up with a way to very deeply mathematically model, right, the kind of underlying stochastic processes that govern, finance, such as, assets and liabilities. As maybe most basic sense, you can think of it as like, just a share of stock, for example, whose value is, um, evolving over time. Yeah, so finance. I didn't put quotation marks there, but I wouldn't be surprised if I stole this from Wikipedia too. Finance is a field that deals with the study of investments. It includes the dynamics of assets, right? So that's our stock prices, but also liabilities, right? Liabilities are like our debts over time under conditions of different degrees of uncertainty and risk. Right, so there's some key ideas. Maybe the most fundamental or most pivotal of them is this idea of asset pricing. Right, asset pricing tends to be modeled by stochastic processes, which is kind of like your next level in kind of like probabilistic complexity. So if you think about like maybe like the mathematical statistics class that you took, where you learned, a little bit of kind of the underlying theory of probability, right? The next class after that would talk about this kind of abstract probabilistic construct called a stochastic process, right? And that's what's used in financial engineering to model these things where you have this like stock price, right? And it's really a process. It's going to have a certain value tomorrow and a different value 2 days from now and a different value 3 days from now. But right, all these values are all going to be interrelated, potentially interrelated with one another. And so, right, rather than like a single random variable, it's this kind of collection or this kind of the sequence of random variables. And so that's what we kind of refer to as a stochastic process. And you can get into things like stochastic calculus. It gets very deep very quickly. If this is something you're really interested in, shoot me an email. And we could talk about maybe some ways to kind of dig a little deeper into it. But barring someone reaching out to me because of like the heavy mathematics behind it, which is um something that we tend to try to avoid in this program, it's not something that I'll probably go into a lot of depth in, um unless somebody reaches out and requests it. But if you wanted to go a little deeper, here's some textbooks. Again, all the textbooks that I'm recommending are all ones that I actually have. So, if you are interested in any of these, don't feel like you got to go on Amazon and order them. I'd be more than happy to loan you any of my books if you shoot me an email. I have some textbooks in SAS too, but I feel a lot of the ones that I really like the best in finance are actually in R. I'm sure there's some nice Python ones out there too. All right. Um, yeah, the next thing that I want to talk about is marketing statistics and analytics. So this is the application of statistics to marketing. Um, it uses a wide variety of statistical techniques from logistic regression, um, a core statistical technique that you'll learn in Stat 507 if you haven't already, to something called principal components analysis. One of its very unique techniques, a methodology that I've only seen used in like the context of marketing analytics, is something called conjoint analysis. So, um, one thing to keep in mind, at the end of the class, you're going to have to pick like a research topic and kind of teach that to the class. Um, so you might be starting to think now, like, which of these subfields kind of sounds interesting to you? And then maybe you could talk to me about, like, okay, I'm interested in like going a little deeper into marketing statistics. And right, if that was the case, then maybe I might say, okay, why don't you look into conjoint analysis and, put together a presentation for the class and kind of what that is and what that looks like. In addition to conjoint analysis, a lot of these are what's considered multivariate techniques. Um, Principal components analysis is very classic multivariate technique used in a whole variety of fields. Something related to that is called factor analysis. There's something called decision trees, which are kind of like a simplification of regression models. Another really big technique in market research is this idea of segmentation. So if you have like a consumer base, maybe you could break that consumer base into different types of segments, right? So for example, maybe you might have like the cost conscious segment, which is like the type of consumer that responds really well to like coupons or discounts. And so you would target them in a certain way, whereas maybe a different segment, right, maybe responds to, I don't know, like active engagement. And you might market your product to them in a different way, for example. So segmentation is a really, really important technique in marketing research, more generally referred to as cluster analysis. And then, of course, right, things like text analytics as well. Um, Generally is used in this idea of market research, right? Like this idea, sometimes it's referred to as sentiment analysis, where you're kind of like parsing through reviews, maybe parsing through social media posts, right? Trying to get a gauge of like what's the general sentiment towards a particular, say, product, for example, positive versus negative. So here's a few textbooks. Right. So I like the Marketing Research by Malhotra. The Research by Marketing Decisions by Greentull and Album's also really good. We're fortunate enough to have two workplace rock stars, the great professors Brian Wynn and Sese Abhulaman, who occasionally come and teach elective classes in marketing research or marketing analytics. So, obviously we can work on it in this class, but if you really wanted to go into like depth, you can put a whole class of it together, and occasionally they do so. I think in a slide back, I kind of skimmed over it real quick. I think I had it out of sequence. There was a slide that mentioned the great professors Rieger and Crosset. They tend to do a lot of work in or teach courses in multivariate analysis, which like goes a little deeper into some of like the more kind of theoretical statistics that kind of powers the techniques used in marketing research. Another big one, in my experience, maybe the biggest one, in terms of like what I see in terms of like job postings, is what's called time series analysis. Although it's maybe more commonly referred to in like a job posting as just like forecasting. So time series analysis is a critically important component of really a lot of these fields, and it's this methodology where our focus is on forecasting. Um, yeah, and that's something that I will make sure that we spend some time in this class going into some depth. But again, like really all of these subfields could be an entire course all on their own. And so my goal is to kind of get you a little bit familiar with all of them. But again, based on kind of your very specific interests, we could go a little bit more or a little bit less deep in some of these things. Um, and then almost finally, right, we have this kind of broader idea. You'll often see this term like business analytics. Um, Again, it's another vague term. I think it's a bit of an offshoot from, right, this idea of data science, big data. Big data was a term. It's really trendy and vogue a while ago, but I feel it's maybe a bit dated nowadays. But back then, when people were kind of first talking about it, they like to talk about these three V's, which was like volume, right, referring to like the size of your data set, right, velocity, which is this idea of this like ever evolving data set that is like if you think about like a supermarket and like people are buying products, they're scanning them, right? Every scan is like new data. So like you just have this constant like influx of data. And then variety, right? Variety was this idea of like moving away from this like traditional rectangular data set to like more novel sources of data. Things like things like reading product reviews or social media posts, or even doing things like analyzing, like using statistics or statistical methodology to analyze x-rays or images or music and so on, right? Big data also, right? And this is maybe the bigger emphasis to me, was seen as focusing on the ability of an implementer to work with, to handle, to manipulate messy, complicated data sets and tell a story while doing so, right? So with respect to that third bullet point, like I actually, I to me the value in this kind of data science, big data, business analytics, data analytics, whatever you want to call it, is I actually really do like this kind of reaction against a school of thought that, right, not that long ago equated the broader field of statistics with a smaller restrictive field of mathematical statistics. And this idea of business analytics really kind of opened it up and kind of moved things beyond the mathematics to include things like messy data sets, SQL, and we'll see in a slide or two, right, data storytelling. Yeah, in fact, here we go, right? So kind of the last thing that we're going to talk about, um, because of course we saved the best for last, is, right, this idea of data storytelling. And to me, data storytelling is kind of like the ribbon that just whatever, chef's kiss, that like ties it all together, that like brings all these, right, otherwise maybe disparate fields, like kind of like unifies them, because like in all of these examples, right, we're using them with some sort of business objective or goal in mind, right? And at the end of the day, right, we're going to learn something, we're going to extract something, we're going to discover a story. And that's certainly part of the work, right? But all that work is really for nothing if we can't share that story, if we can't tell that story, and in particular if we can't do that in an effective way, right? And so, um, right, obviously, if you want to learn more about data storytelling, we're fortunate enough to have an expert in the field, working with us, and that of course is the great Professor Velez. So I won't steal her thunder, but she'll have plenty to say. I'm sure about that. And so yeah, there we go. I think that concludes our introduction. We'll segue from here, probably to some econometrics. Um, yeah, so buckle up, buckle up, buttercups, because we're on for a pretty crazy but really fun ride.